4.7. Use isosceles and equilateral triangle. On an isosceles triangle, this angle here that is located where the two congruent sides and opposite the base is known as the vertex. Here's the two congruent sides. Those are known as legs. These are the base angles. They're also congruent to each other, because if two sides are congruent, then two angles have to be congruent. Theorem 4.7, the base angle theorem, states that if the two sides are congruent, CA and BC in this case, then the base angles are going to be congruent, angle A and angle B. The converse of this is talking about the angles being congruent and then the sides. So if angle A is congruent to B, then the sides AC is congruent to BC. Corollary to this theorem is the equilateral triangle. If XY is congruent to YZ and it's also congruent to ZX, then we know that all the angles have to be congruent as well. It's just like if all the angles are different angles measures, then the sides are going to be different measures, and vice versa. Two sides are congruent, two angles are congruent. If three angles are congruent, three sides are congruent. Corollary to theorem 4.8 is saying the converse. If the angles are congruent, then the sides are congruent.